Now in this video I'm just going to provide some additional explanation of what's happening with the simulator here and how you can modify the behavior of the robot. So as before, you can see it's running the example code here, which is just going to guide the robot around the first bend, but it'll run into a problem when it gets to the second bend because it's only controlling the motors to turn in one direction when it detects that green pattern on the ground. So essentially what's happening with this simulator is it's very similar to what you would have with the real robot that you're going to build in RoboSumo, in that the robot has got two motors, one on the left and one on the right. Both of those motors can be controlled bidirectionally. In other words, each motor can be driven forwards or backwards. So that allows the robot to drive either forwards or backwards, or to turn on the spot clockwise or anti-clockwise. In order to turn, you just drive the two motors in opposite directions. What it also has on its four corners are these color sensors. So what they're reading is a kind of a numerical value which represents the color of the ground underneath that corner of the robot. So that's how the robot is detecting where the edge of the road is, and the computer program that we write for it is going to use the four numbers that it reads from those four sensors to make a decision over and over again very quickly about what the motors need to be doing at each point in time. And that's what the code is going to do. So there's a couple of keyboard shortcuts that you need to control the simulator. First one, if you want to reset the robot position back to the start at any point, you just hit the space bar. So that's just what the space bar does. It moves the robot back to that kind of blue, dark blue and light blue start position marker. So anytime you hit the space bar, it's going to move back there. The other keyboard shortcut you need to know is either the Q key on the keyboard or escape will cause it to exit the simulation. Now when the simulator closes, it still leaves open this black terminal window, and this can be useful for us actually because we're going to be able to print out some information from the program using this window here. However, you won't be able to update the program and run it again until the black window is also closed. So you can see there it's saying press any key to continue. So I'm just going to press return here, and that will close the black window. So let's imagine we were going to make a change to the program. The only file that you are going to need to edit to modify the behavior of the robot is this file robot.cpp. There are other files contained in the project here which actually run the simulator itself, but you won't need to edit those at all. The only one you need to change is this one here. And the code in robot.cpp looks very, very similar. In fact, it's identical to the kind of Arduino code that you would have running on the physical robot that you're going to build. So we'll learn more about the Arduino code during today's lab, and I will explain some of it in the lecture. So hopefully by the time you're watching this video, you'll already have seen a little bit of this explained during the lecture. But Arduino programs contain at least two functions. So they always contain a setup function and a loop function. So the setup function in this case is everything between these two brackets here. And this is a set of instructions which will be carried out just one time when the Arduino powers on first. So every time you switch on the Arduino, these instructions here will be carried out. The second function is everything from here down to here. So again, it's enclosed in a pair of curly brackets. Sorry, not sure what I've done there. It's enclosed in a pair of curly brackets, but the loop function is a set of instructions which will be repeated over and over again as long as the Arduino remains powered on. So this will be some kind of, in the case of our robot, this will be a decision-making process which is happening over and over again, reading information from the sensors and deciding what the motors should be doing. So in my example here, very briefly, what this is doing is in the setup function, I need to designate 4 pins on the Arduino as digital outputs, and that allows the Arduino to control voltage on those pins. So the first 2 of these will control the left motor, and the second 2 will control the right motor. You'll see that I've included comments here. Anything in the program here which follows a double forward slash is what we call a comment, and that means that the Arduino and the computer will ignore that text altogether. It's just there for the information of any human reading the program, but it won't affect what the program does. So the comments that I've included here just identify what each of these lines of code is doing. The first one here is just setting the left motor forward pin as an output. The next one is setting the left motor reverse pin as an output. So basically, in order to make the left motor drive forward, we would set pin 2 to be high and pin 2 to be low. But in order for them to be set either high or low, they have to be outputs. So unless a pin is an output, the Arduino is not able to actually control the voltage on it, so it wouldn't be able to control the motor that's connected to those pins unless we actually set them as outputs. We do the same thing for the right motor here. These are the forward and reverse pins for the right motor. There is also a line here called serial begin 9600. What this is doing is it's establishing a serial connection between the Arduino and a PC if it's plugged into a computer. Now in the simulator, it's always able to print to the terminal window, so you'll be able to see if you use the serial connection to print out any values while the program is running, you'll be able to see them appear in that black terminal window that we saw before. So this just opens the serial connection. So that's basically all of the setup that needs to happen in our program. Once that's done, we move into the loop function, which will be repeated over and over again. So in the loop function, I create a variable called FLS, that's short for front left sensor, and that is an integer variable, meaning that it can store a whole number. So it only stores one number at a time, but the numbers that are stored in there have to be whole numbers. They can be positive or negative or zero if it's an int, but they must be whole numbers. Now in practice here, all of the numbers that we get back from the sensor are going to be numbers between 0 and 1023. So none of them actually will be negative in this case, but that's what that variable will be used for. This line here on line 37, it reads an analog voltage on pin 0, and that's where the front left sensor is connected. You can see at the top of this file in the comments I've identified which pins are connected to which sensors. So analog input 0 is connected to the front left color sensor. So I'm reading that sensor here using the analog read function. That's one of the standard Arduino functions. We get back a number between 0 and 1023, and we store that number into our variable FLS, front left sensor. So if the number was 0, that would mean that the color at this point in time underneath the front left corner of the robot will be black. If we got back a value 1023, that would tell us that the color underneath the front left corner was perfectly white. And if we get a number somewhere in between, it just tells us that the color is somewhere in between black and white. Now it's kind of seeing the colors in like monochrome. So it's seeing them as like shades of gray. It can't differentiate between different colors like red, blue and green. It's only able to see how bright the color is. So you just get a number between 0 and 1023, and that's all the robot sees, but it sees it under each of its four corners, and then it has to make a decision about what to do with the motors based on those readings. In this example, I'm only using one of the sensors, but you will need to rely on more than one of them in order to make decisions to guide you all the way along the road to the parking space. So once we have stored the number in there, which represents the current color underneath the front left corner, then we use an if statement, or rather an if else statement, to choose between two different possible actions that we could do with the motors. So the first one is that we could drive straight forward, which is what these four lines do. The other option is that we could turn around on the spot, so we could spin right, meaning that the robot will turn clockwise. And we do that by driving the left motor forward and simultaneously driving the right motor in reverse. And that means the robot will spin on the spot. So they're the two possibilities. The robot either drives forward or spins to the right. And the way that we choose which one of these to do is based on the value that we got back from the sensor. So if the value was very low, like less than 100, which would be less than 10% of its maximum value, that indicates that the surface underneath the sensor is very dark. So in the simulator, that basically means it's on the road. So in this case, as long as the front left sensor is on the road, the robot will drive forward. However, if the front left sensor finds itself over a piece of ground where the color is a brighter color, the number stored in FLS will actually be higher than 100. You know, it could be as high as 1023 if it was on the white parking space at the end of the track. So if if FLS contains a higher number than 100, this statement here will be false. FLS will not be less than 100, in which case it will choose the second option here. Now it's important to understand that this loop function is repeating over and over again many times per second. So it takes it only a fraction of a second to read the sensor and to make this decision and to update the state of the motors. So basically it's constantly monitoring the sensor and making the decision over and over again about what to do with these motors. So if we were going to make a change to the program here, let's add in something simple. I'm going to use serial print here to start printing out the numbers that we read from the sensor. So what this does is serial print will print out whatever number is stored in FLS, and then I'm also going to print out a space immediately after it, just so we don't get a big jumble of numbers all crammed together on the screen. Because remember that this is going to happen over and over again many times a second. So anytime you make a change to robot.cpp, you need to build and run again to see what the effect is on the behavior of the robot. So I'm going to click that build and run button on the toolbar. And now you can see that the robot is moving up the track, but we're also printing out a lot of numbers as we go along here. And what you'll see is that most of the numbers that are coming up are zeros. And that just means that at the moment in time that the sensor read that number, it was on the black road. However, you can see that interspersed with the zeros are some higher numbers, which is basically whenever the front left sensor dips into the grass area just off the road, it reads higher numbers. And there's certain points where the robot is spinning around where you get a whole string of higher numbers in a row, like we're about to get it here, just where the sensor happens to be over the grass for several readings in a row. So that'll give you some idea what kind of numbers you're reading from the green surface. Now it won't be it's not a uniform number all the time for green, because the green color of the ground there is kind of mottled, so it's darker in some patches and lighter in others. But you can see roughly you're getting values in the kind of 300 and 400s. Now when you get to the parking space at the end, if you can get the robot to go that far, you'll see that the numbers will read a lot higher. Like they should be up well over 1,000, I would say. The maximum value is 1,023, and it could be quite close to that. Okay, so I'm going to press Q to exit out of the simulation here, and then I'm going to press return to close the terminal window. Now, just to show you, this isn't going to be a useful change to the program, but I'm just going to make another change to alter what the robot is doing. So at the start, instead of getting it to drive forward, I'm just going to get it to drive in reverse. So I'm going to make a change here. I'm going to set the forward pin low and the reverse pin high. And I'll do the same for the right motor. So this will be both motors will be driving in reverse. And I'm just going to take away these comments here because they'll be confusing now. And it's always a good idea to keep your comments up to date with any changes that you're making to the code. So anytime you change this file here, you just build and run to see what the effect is on the robot. So I'm going to click build and run here. Now we're not expecting this to be a very good strategy. You can see there that the robot has basically just reversed itself off the road, and now that it's on green all the time, the front left sensor is constantly on green. It's just spinning in the same direction the whole time. So I'll just hit the space bar to return it to the start position, and we'll see if it does the same thing again. Yeah. So obviously this is not a useful strategy for getting the robot towards the parking space, but I just wanted to show you the process of how you modify and build the program again to try changing the behavior of the robot. So that's that. Just another couple of things that might be interesting to see here. If I open up the folder, so I'm bringing up Windows Explorer here, and we're just going to take a quick look into the Johnny805 folder. You can see within this folder that there's a couple of PNG files. So if you see here in the file type, you can see ground.png and you can see robot.png. So these are just the images. There's the image of the robot. It's just stored as a PNG file. And here is the image of the ground. So this blue, light and dark blue marker sets the position where the robot will begin each time you run the simulator or when you press the spacebar. So what you might find later in the challenge is that it's convenient to just start the robot closer to the parking space here when you're trying to figure out how to get it to park in the space there. So you could edit this image yourself for the purpose of testing and just just paint over this with pure black and then take this part of the image and paste it in somewhere over here so that you can change the start position of the robot just to test the last bit, because it takes 30 or 40 seconds to drive up the track to get to here. So that's just something you could try doing yourself if you were interested. So I think that's pretty much it. I'm just going to leave it there for now, but of course we'll have more discussion about this during the lab later on. Thank you.